everyone. We're going to state the number and type of solution for each quadratic equation. We have 3 examples and they all have k in them, so these are going to be a little different. We're going to use the discriminant. So basically using the discriminant, this one right here, to determine our kind of solutions. For our first one, we have kx squared minus k plus 5x plus 1 equals 0. So for our discriminant, we need our a, this is your a, equals k. Your b is going to equal negative k plus 5. And your c is going to equal 1. So using your discriminant, you're going to get d equals b squared. So when you square this, the negative is going to go away. So we can just get rid of that. So it's going to be k plus 5 squared. Minus 4 times k times c. Now, simplifying this, we're going to get k squared plus 2ab. So that's going to be 10k plus 25 minus 4k. This is going to give you k squared plus 6k plus 25. We can also write this as by completing the square here. I'm going to complete the square. I'm going to get k squared plus 6k. You take half of 6 and you square it, so that's going to be plus 9. But then you have to subtract 9 too. So you add 9 to something, you have to subtract it. Plus 25. And then we can simplify this as a perfect square trinomial as k plus 3 squared plus 16. All right, is this positive or negative? Well, we have to look at each piece. This part is positive because no matter what you put in for k, once you square it, it's going to be positive. Plus, you're adding a positive number. So this is going to be positive. That means we have 2 intersection points. That means 2 different real number solutions. So that's why these kind with the k are a little bit harder. You have to look at it a little more carefully. All right, so the next one is this one. We have a equals 3, b equals negative 1 for here, and c equals negative k squared. So using our discriminant, we're going to get b squared. When you square that, that's going to be positive 1. Minus 4 times 3 times c. So it's negative k squared. All right, looking at this, we're going to get a 1. We have 2 negatives. That makes a positive. That's going to be plus 12 k squared. All right. And again, just like we did before, this is going to be positive because whatever we put in for k, even a negative number, this is going to end up being positive. So you're adding a positive plus a positive number, it gives you a positive. So again, since our discriminant is positive, we have 2 intersection points, which means 2 different real, I'm just going to put real solutions here, real number solutions. And then let's do the last one. So for the last one, let's write down our ABCs. Our A equals 1. Our B equals negative 4k. That's your coefficient. And our C is all of this. So your C is going to be 5k squared plus 1. All right, so this one looks a little harder. Our discriminant is going to equal b squared. So when you square this, you square the b, you're going to get 16k squared. So it's going to be 16k squared minus 4 times A. I'm not going to, the A, I'll just put 1, times C, which is going to be 5k squared plus 1. Therefore, we're going to get 16k squared minus 4 times 5k squared plus 1. All right. So basically looking at this is going to be positive. And then we have minus 4k squared minus 4. So what we have is we have this positive, and then we have, this is, whatever we get here is going to be negative, and this is going to be negative. So basically, if I rewrite this, I can write this as negative 4k squared minus 4. If I expand this whole thing, so 16k squared minus 20k squared minus 4, that gives me this. So basically, whatever you put in for k squared is going to be negative. It's going to be positive, and then we have to negate it. And this is also a negative number. So we have a negative number and another negative number. And when you add those up, you get negative. So that means there's no real number solution. It's right here. There's only complex solutions. Thank you. Have a nice day. Bye-bye.